Assalamualaikum and hello. My group is from CS143 5B. So today we will present about mixture, which is from the chapter 3 application of first order differential equation. Before we start, I will introduce our group member, which is including me, Nur Nabila Abu Qasim, Siti Nur Zaika binti Salim, and Putri Nur Atikah Munira binti Ibrahim. Mixture is a substance made by mixing other substances together. For example, cement is a mixture of sand, water, and gravel. Seawater is a mixture between water and salt, and gasoline is a mixture of petroleum, hydrocarbon, and food additive. Mixture problem involve combining two or more things and determining some characteristic of either the ingredient or the resulting mixture. For example, we might want to know how much water to add to dilute a saline solution, or we might want to determine the percentage of concentrate in a jug of orange juice. Formulating of model and method of solution. Formula that involved in mixture problem is inflow rate of the solution and outflow rate of solution. Formula for inflow rate of solution is dV over dt inflow equal to R1, and for outflow rate of solution is dV over dt outflow equal to R2. Unit for both solution is liter per minute. dV per dt is the rate of solution entering or leaving. Besides inflow and outflow rate of solution, concentration of the inflow solution also involved in mixture problem. The formula for concentration is dA over dV inflow equal to C1. The unit for concentration is gram per liter. dA over dV is the concentration of the substance in the inflow or outflow. Mixture problem can be modeled as the following. dA over dt input equal to input rate of the substance minus output rate of the substance. The formula for input rate of the substance is dA over dt inflow, meanwhile output rate of the substance is dA over dt outflow. To find dA over dt, we can do conclusions such as dA over dV multiply with dB over dt. dA over dt is same with Ci, meanwhile dV over dt is same with Ry. Based from mixture problem model I show, AT is the amount of a certain substance at any time. BT is the volume of solution at any time. dA over dt is the rate of change of the amount of the substance. Meanwhile AT over BT is the concentration of the substance at the time. Standard linear differential equation from the problem is simplified as dA over dt plus R2 over Vt multiply with A equal to C1 R1.
They are as step. First, list out the value of each term value. Second, find the value at time. Third, find the concentration of outflow solution. Fourth, the linear differential equation formed by the substitution from the equation. Fifth, use the integrating factor. 6. Multiply both side equation in step 4 with the integrating factor. 7. Integrate both sides. And last, solve the problem using the information given.
A liquid volume of 9 billion is polluted with nitrate with concentration of 3 billion. The water that flowed in has 100 million nitrate pollution. The water flow in at a rate of 500 million per day and flow out rate of 400 million per day. How many nitrate after 1 week? We estimate 3 billion is 3,000, 5 million, 9 million is 9,000, 100 million is 100,000, and so on. We remove 9 zero digits to simplify the calculation. Step 1, list out the value dA over dV in equal to C1 equal to 100, initial volume VO equal to 9,000, outflow rate R1 equal to 500, inflow rate R2 equal to 400. The initial amount of nitrite A0 equal to 3,000. Step 2, we find the volume at time t. Substitute R1 and R2 into the formula Vt Vo plus R1t minus R2t, and we get Vt equal to 9,000 plus 100t. Step 3, find concentration. We substitute 9,000 plus 100t into formula C2 equal to 80 over Vt, and we get to C2 equal to 80 over 9,000 plus 100t. The linear differential equation is formed by substituting from equation dA over dt plus R2 over dt multiplied by A equal to C1 R1. Substitute R2 equal to 400, Vt equal to 9,000 plus 100, C1 equal to 100, and R1 equal to 500 into equation dE. Use integrating factor. Exponent power of integrating Pt dt. From equation we know that Pt is 4,000 over 9,000 plus 100t. After integrating, we get exponent power of 4 ln 9,000 plus 100t. We can move 4 and we can get exponent ln 9,000 plus 100t power of 4. After simplify, we get 9,000 plus 100t power of 4. Step 6. Multiply both sides of the equation with integrating factor. 9,000 plus 100t power of 4. Integrate both sides. Because we must to integrate a high power, we must to let u equal to 9,000 plus 100t. Make a difference for u, and we get du equal to 100 dt. Substitute u and dt. After integrate, we get 500 multiply u power of 5 over 5 plus c. Substitute u equal to 9,000 plus 100t. We can simplify 5 over 500 over 5, and we get 100 multiply 9,000 plus 100t power of 5 plus c. Move 9,000 plus 100t power of 4 into right hand side. So we get A equal to 100 multiply 9,000 plus 100t plus C multiply 9,000 plus 100t power of negative 4. Solve the problem using the information given. Apply A0 equal to 3,000 to find C. C equal to 1 over 3,000 multiply 9,000 power of 4. The amount of creative substance 80 is equal to 100 multiply 9,000 plus 100t plus 9,000 power of 4 over 300 multiply 9,000 plus 100t power of negative 4. In equation, we must to find amount of nitrite after 7 days. We must to make 7 as t. After that, we can get answer 970,000. Don't forget to add 60 to final answer. The real answer is 970 billion.
Mixture problem are the excellent candidate for solving with system of equation and method. To solve them, it is important to first recognize the content within which the problem occurs and to identify a formula that can be used to represent the different quantity within the problem. Mixture problem can often be set up in a term of a single variable, although some people may prefer to set up them as two variable system.